Yeah, I don't know about you guys, but I think I might need new glasses. We built this piano synth kit, I don't know, a few days ago. And it works. Plug it in here. Kind of got an interesting sound to it. We looked at the waves and they were kind of ugly. And then two of you guys, Moon Brony and Mike Oliver, who obviously have better eyes than me, pointed something out. So let's zoom in. Okay, we have two electrolytic capacitors here on the board, which are generally used for DC blocking in circuits like this. This is the first one. You'll notice positive side here, negative side here. There's a stripe for the negative, but on the second one, somebody, namely me, soldered it in backwards. So, perhaps we're missing some DC blocking, and perhaps if we switch it around, it'll work better. Although we might have shot that capacitor, but not to worry, I have more. So I've got the soldering iron warmed up, and I've got the desoldering needles out. It's probably a 1 millimeter. Now we'll try it and see if it works. So these two pads right here that I'm pointing at, let's zoom in. Those are our pads. Let's see how we can do. Hopefully I can get them out. But then again, we've already proven that my eyes aren't that good. You have to go bigger. Try this guy here. Well, it's on top of it, but it's too big for the hole. So we'll go with the yellow. Is that too big for the hole too? Shouldn't be. Come on. Man, maybe I really do need new glasses. Alright, give me a second. There's one. Now let's see if I can get the other one. I should probably be doing this under my magnifying microscope, huh? Wow, I really can't see those leads. Alright, give me another second. Sorry, guys. Wow, my eyes really are bad. But we got it out. So I'm going to go find another cap and we'll be right back. Okay, got another cap. Matching voltage, just a little bit lower in capacitance, but since this is only a DC blocking capacitor, I'm going to take a chance at it. Should be fine. Now, you guys all remember what it sounded like before, right? Hopefully, it will sound better now. Done soldering, so clean off the soldering iron. Add a little fresh solder to the tip before I put it away to keep it from oxidizing. Alright, let's zoom out. And we'll clip the wires. Hook up the battery. Turn her on. I don't know, it doesn't sound any different to me. Let's put it on the scope and see what we get. Okay, I've got it hooked up. I got the ground hooked to our ground, and I'm going to probe at the output here instead of right on the speaker. So let's go up to the scope. We'll take a look here. Here's the lowest note. Here's the highest note. Middle. Let's zoom in here so we can see the frequencies. This is AC coupled. Looks like you see a small carrier there. Well, that's interesting. We were getting a good response before, now we're not. What's going on? I'm going to try and zoom in here. Okay. 877.6. It's a little closer. Now, this is a 555 timer-based circuit, so it's only going to output a square wave. But if you come down here and look, we do have some filtering going on. Cap resistor. So that's why we're seeing that kind of overwhelming waveform. Now, take a look at this here. I'm going to probe the output. Then I'll play a note. Let's bring that in a little bit better. So you can see the square wave with the spike at the attack and at the delay. You can see a little bit of capacitance in there. Very interesting. Let's go up to the higher frequencies. Here's the highest note it plays. I don't know, I swear I can almost see a little bit of a carrier wave modulation going on there. Let me try something here. Looks like I can almost see it. Interesting, isn't it? Well, anyway, thanks to Moon Brony and Mike Oliver. I corrected the problem here with the reverse bias capacitor. So thanks for the call on that, guys, and hope you enjoyed this video. If you did, give me a thumbs up. Big thanks to all the patrons. That's it. I'm out. Peace. Here comes a train.